Assalamualaikum and hi. Greetings to all the panels involved in this final year project one. Big thank you to all that is involved in the succession of this final year project. I would like to express my gratitude and a big thank you to my supervisor, IR Dr. Amir Razi Abdul Ghani, for guiding me through the succession of this final year project proposal. Other than that, I would like to thank you to professional technologist Dr. Zaino Helmi Solihin that act as the coordinator for this FYP1 for helping and guiding us throughout the completion of this final year project proposal. My name is Amri Yusuf and my student ID is 2019312323. My final year project title is as stated in the slides, which is Rollover Crash Analysis on an Electric Bus. So in this presentation, the content is as stated that the first one, project summary, and then introduction, the third one, literature review, and the problem statement. After that, we have objectives and scope and limitation, and then we have methodology, and last and but not least, the expected results. So for the project summary and electric bus is going to be designed and a rollover test on the design chassis will be performed. The designing process will have various safety requirements to be taken into account to ensure the safety of the passengers as well as the equipment in the bus such as the battery pack, which is sensitive if the safety fails. The UN ECE regulation number 66 is the one of the safety requirement will be included into the design. The rollover crash analysis will be performed using finite element analysis, uh, and the modeling of and designing process will be using SolidWorks, while the analysis of this project will be executed in Abacus. So for the introduction, in automotive design and development, the chassis design and strength of the most are the most important things that need to concentrate on to ensure the safety of the passengers, especially in public transportation such as a bus. As electric-powered buses are relatively new in Malaysian market, the chassis structure needs to be newly designed and researched as the traditional gasoline-powered buses equipment are different. An electric-powered bus chassis need to allocate space to be stored the battery as well as the uh, electric equipment. This research is focusing on designing the structure of the bus. Various type of beam section and frame configuration have been modeled, and the rollover crash analysis will be conducted using the finite element analysis. Finite element analysis is an alternative for automotive crash test analysis. The real experiment required a lot of resources to conduct, so that the finite element analysis application helps engineers to be able to design and identify problem virtually and precisely. By minimizing the physical experiment onto the structure, the cost and time of experiment can be reduced as well as boosting the productivity of design process and development. The design of the structure is tested accordingly to pass the UN ECE regulation number 66, which the structure must protect the residual space in the bus from collapsing before and after the crash test analysis. So the main problems for this project are uh, the higher stress and deformation of the superstructure and the lightweight design of superstructure for power consumption reduction and increase the traveling range. So for the objective of this study, to determine response of bus structure subjected to rollover crash. The second objective is to determine the effect of the beam cross-sectional shapes and sizes on the impact response. And the third objective is to determine the optimum bus structure configuration for rollover impact. And then for this project scope and of this project, the scope of the project is to design a lightweight superstructure and leather frame chassis made from steel for a 20-footer electric bus. The design chassis must be strong enough to withstand the force in case of an accident occur to protect the passengers and crews in the bus. The accident will be depicted as a rollover situation. The analysis will be conducted by using the finite element method, which is using the Abacus software. The superstructure chassis were designed with various configuration in Abacus. The behavior of the superstructure will be observed to see if the deformation will be affected the residual space according to the UN ECE regulation number 66. The research will be focusing on the analysis virtually using finite element method only as the actual experimentation was obstructed by the pandemic COVID-19. For the literature review for this project, first thing first is the finite element method. With new technological advancement in design and analytical software, it helps a lot of engineers to investigate the frames of a vehicles. Richard Sono did a rollover bus testing on an existing chassis from an Indonesian company, which is the R260 model. The flexibility offered by finite element method enables the engineer to be able to add more complexity to the design without the additional cost involved. Finite element method allowing the structure design to be modified for optimization to increase the crashworthiness, which is cited in, in number 3. Therefore, finite element method increase the efficiency and speed of obtaining the data of the analysis without sacrificing accuracy and reliability. The configuration of the structure to be lightweight can be manifest and analyzed using finite element method without any wasted material if the analysis is done in the real world. The most affected parts of the design can be identified and optimization work can be worked on, which is cited on number 4. An analysis of vibration characteristic performance regarding the possibility of resonance on an electric bus can be done with low cost by excluding the making of the real prototype to obtain the natural frequencies, which is cited in number 5. So for the second literature review, title is UN ECE Regulation number 66. The rollover of a bus is the most feared accident, and the risk of injury to the passengers is the primary concerns. So in the article number 6, the residual bus space must not be affected when the rollover happen during and after the accident occurs. The residual space is a space retained for the driver, passenger, and crew for the survival possible in case of an accident. There are a few testing methods regarding the regulation, which are rollover tests on complete vehicle, tests using body section, quasi-static loading test of body section, quasi-static calculation based on testing of components, and computer simulation of a rollover test on a complete vehicle. So for the structure optimization, the article number 7 analyzed 3 types of steel on a Mercedes-Benz OF 9170 leather type chassis. Out of the 3, the von Mises and stress result were of AISI for 130 alloy steel is the lowest compared to other 2 types. The most critical part of the chassis is at the front of the structure. The article number 3 suggested building the superstructure with the rectangular twin wall beams, DRTWB, to furtherly strengthen the superstructure of the bus by analyzing both regular rectangular twin wall beams. The strengthening approach is achieved, but sacrificing weight is not the main objective of this research. To achieve a lightweight design of bus structure, article number 8 suggested that the building of the superstructure using multi-material topology optimization. However, the structure building process complex for manufacturing and reduced welding coefficient make it less stiff compared to single material topology optimization. Fiber reinforced polymer structural design was studied to analyze the crashworthiness and strength, which is cited in the article number 9. The study shows that the variation of core and face thickness has a significant effect when changing the design parameters. Reinforcement is also required on the battery storage system, which is crucial to avoid the accident if the battery got breached on collision. Stanislav Spurk et al. In article number 10 analyzed the REES rechargeable energy storage system to test whether the system can withstand the stress and impact under acceleration. The result and of the simulation shows that the heavy stress part is the bracket holding the REES and no failure occurs. The last cited uh, article is the Economic Commission for Europe of UN. According to the regulation, the residual space must not be affected when the rollover happens during and after the accident occurs. So for the methodology of this project, first thing first, start and then we go through the literature review, and then we design the superstructure, and then the design was analyzed with finite element method, and then we got the analysis result. If we got any problem on the analysis result, we go back to design the superstructure if there any problem, and we also uh, revisit the analysis method. So then the final step is the documentation and presentation. So for the design, the superstructure for this research paper, superstructure chassis of an electric bus is required to be designed. The parameters and dimension were determined during this process. The dimension of 6 meters with height of 2.5 meters and the width of 2.1 meters were designed with various configuration. With a passenger capacity are estimated at 36 people, the weight of the bus is 6 tons. For the structure hollow section, steel material with a weight of 50 millimeter and 3 millimeter of thickness. The material properties of the structure is steel. The analysis in the final element method is modeling the superstructure with the length of 6 meter, the width of 2.1 and the height of 2.1 meter. To perform the analysis, the model of the superstructure need to be set up in Abacus. The information of the analysis needed to be precise for the result of the analysis to be perfect. The analysis required to mesh the model of the superstructure, and then we applied the boundary condition of the analysis and create the floor to roll over on, and apply dynamic explicit on the model with the angular velocity of 2 radian per second at which the chassis hit the ground. We also set up the contact point with friction coefficient of 0.3, and then we create a job and submit, and we get the analysis result. The obtained result from the finite element method analysis will be observed. The deformation of the superstructure will be examined to ensure the deformed model does not breach the residual space. The area that has higher stress will be revisited and will be made changes to the design of the model at the affected area. And then lastly, we made the documentation and presentation. The proposal of the research and the result obtained were prepared and compiled. The presentation video is recorded and uploaded to YouTube for the panel to judge. The expected result, as we can see here, cited from the article number 1, we can see that the structure deformation breached the residual space, which is made the configuration of the structure fail. From the from my result that we obtained, uh, we see that clearly the displacement and stress, respectively, the maximum displacement of the upper part of the structure that I gain is 2.197 meter, which is not safe for the public. Where the stress of the structure it reaches the maximum at 5.62 megapascal. The highest affected area in terms of displacement is the upper part of the structure, where the highest stress affected the bottom side part of the structure, where the impact occurs. Comparing to the actual superstructure, this infrastructure needed major improvement in terms of uh, structural design and configuration. The most affected region needed to be strengthened to be able to cope with impact without breaching the residual space according to the UNECE regulation number 66. So this is my Gantt chart for this final year project to fulfill the flow of this project. We have to make this Gantt chart. As you can see here, this is my Gantt chart. And then that's all from me. Thank you. And for the Q&A session, you can kindly contact me through the number that I've given in your feature. Thank you for lending me and giving me this opportunity to present my project. And thank you to all the panels and my supervisor. Thank you, and that's all from me.